Hello everyone, in this video I'm going to be making an introduction to homogeneous video, and this will be the first video. So first I'm going to explain in what kind of questions we use homogeneous. So here I wrote, when repetition is allowed for the three numbers 1, 2, 3, pick 6 numbers. So it could be like, we're picking 6 numbers, and since repetition is allowed, we can repeat any of these 3 numbers. So it could be 1, 1, 2, 2, 3, 3. Or it doesn't say that we have to have at least one of them, so it could just be all 1s, all 2s, or whatever. So there are many possibilities for this, and this type of question, that is when we use homogeneous. So we have 3 numbers to pick from, and we're going to pick 6 numbers when repetition is allowed. And this is 3 homogeneous 6. And how would we solve for 3 homogeneous 6? Well, we're going to use the combinations. And so first, what this basically means is if we have 6 spaces, and if we were to put arrows anywhere, so like if I put an arrow over here, then the way this would be numbered is 1, 1. So after the arrow, after a arrow, the number, you add a 1 to a number in front of the arrow, so it would be 1, 1, 2, 2, 2, 2. If the arrow was in the front, then that would just be all 2, 2, 2, 2, 2, 2. And if the arrow was all the way in the back, that would just be 1, 1, 1, 1, 1, 1. And so, but here, how many numbers would we be able to fill in these 6 spaces with? Only 2 numbers, right? 1 and 2. There is no way that we could get the 3 in some space over here in the 6 spaces, and that is why when we have 6 spaces and trying to fit 3 numbers, we need 2 arrows. So if we have 2 arrows, like 1 here and 1 here, then this would allow us to be able to use 1, 2, and 3, all 3 numbers. We don't have to use all of them, but we still need to be able to use all 3. 1, 1, 2, 3, 3, 3. And now let's take a look at if we had 6 spaces but 4 numbers to put in. If we had 4 numbers, 1, 2, 3, and 4, that we would want to fit in, we don't have to fit all of them in like we did here, then we would need 1, 2, 3 arrows. So you see, we were able to fit in all of the 4 numbers. But if we only had 2 arrows, there is no way that we could have even had the 4 in one of the spaces. And now let's do, if we had 6 spaces and five numbers that we want to be able to fit in. 5 numbers. 1, 2, 3, 4, 5. Well, then we will need 4 arrows. 1, 2, 3, and 4 to be able to fit in all 5 numbers. 1, 1, 2, 3, 4, and 5. So if you realize a pattern, the number of numbers that we have that we want to be able to fit into the 6 spaces, we subtract 1 from that number to get the number of arrows that we want. So here we had 3 numbers that we wanted to be able to fit into the 6 spaces. So we subtract 1 from 3. 3 minus 1. And so that would be 2. And so basically we have, and the arrows can be anywhere, right? So we have the 2 arrows with the 6 spaces. So basically we have 3, 4, 5, 6, 7, 8 spaces where we can put a number or an arrow. So that will be 3 minus 1 plus 6 spaces that we can choose from. And we're going to choose 6 numbers to put in. And so if we calculate this, that will be 2 plus 6, which is 8. Choose 6, which is equal to just 8, choose 2. 8 minus 6. And 8 choose 2 is 4 times 7, which is equal to 28. And so there are 28 ways to pick 6 numbers when repetition is allowed, and we just have 3 numbers to pick from, 1, 2, and 3. So now I would like to write the formula for homogeneous and how to convert that into combinations. N homogeneous R is equal to n minus 1 plus R. Choose R. So this was the first video of the introduction to homogeneous, and I hope you'll watch the next one. Thanks for watching, everyone. Bye.